Okay, so I'm John. I'm a developer at the San Francisco office, and I work on the integration team. I'm going to be talking about the plugins to system, not gadgets to, plugins to, and OSGi and the OSGi system. And the reason I'm giving this talk is because my team, the integration team in San Francisco, does a lot of work with cross-product plugins. So we built things like the Jira 4 dashboard, and the open social gadget stuff that you see there. That's all plugins to cross-product plugins. And we also built the new Universal Plugin Manager. So we're pretty intimately familiar with building large cross-product plugins, and we're pretty intimately familiar with the plugins to system. So I thought it'd be a good thing to give a little bit of an overview of plugins to and how it interacts with OSGi and problems that you might run into as an OSGi developer. This talk is pretty technical. It's kind of geared towards intermediate level plugin developers, so people who have built maybe a plugins 1 plugin or a simple plugins 2 plugin and want to learn a little bit more. But there should be something in here for everybody. If you're just getting started with plugin development, I'll give you guys a primer on OSGi so you can really learn the fundamental concepts that you need to know to build Atlassian plugins. And if you're an advanced developer, I've got some tips and tricks in here that'll be very useful for you in speeding up your plugin development and also debugging OSGi issues, and then finally making your OSGi plugin maximally compatible with the OSGi container that we use in our products. So brief agenda. I'm going to begin with like a 10,000-foot view of OSGi and just describe why we use OSGi in our plugin system. And then I'm going to dive a little bit deeper with a little bit more technical detail on OSGi itself. Now, I'm not going to try to make you an OSGi expert in 45 minutes, but what I am going to try to do is give you what you need to know in order to build Atlassian plugins, and really what you need to know about OSGi. And the vast majority of my talk is actually going to be a set of pro tips, some helpful tips and tricks that you might want to know when you're doing plugin development. So here's my 10,000-foot view architecture slide of OSGi. If I was to define OSGi in one sentence, I would describe it as a dynamic module system for Java. Breaking that definition down a little bit, first off, it's a module system. So it breaks up your Java application into a set of modules which are encapsulated or sandboxed from each other. The unit of modularity in OSGi is called a bundle. So the notion of a bundle kind of pervades everything in the system. Bundles can talk to each other. I'll describe how that happens. One way that they do so is via service layers. So services allow bundles to talk to each other. And part of my definition was that it's a dynamic module system. The dynamic part is something kind of new in the Java world. So there's a lifecycle layer in OSGi, which basically allows bundles or modules to be dynamically installed, updated, stopped, restarted, and so on and so forth. That's something that you haven't really been able to do in traditional Java applications. And we'll see why that's powerful a little bit later. Now, all of this stuff is tied together by an execution environment that manages the lifecycle, the services, and the communication between bundles. So that's kind of OSGi at the highest level. Now, I'm going to be talking a lot about pain points that you'll run into when you're doing OSGi development. So I think it's very useful to step back a second and wonder, why did we actually insert OSGi into our plugin system? So I want to talk about the benefits for a little bit before I rip on OSGi later. So the first benefit, I think one of the most important ones, is encapsulation or sandboxing. So prior to the plugins to system and OSGi, it was really possible for one bad plugin to take down the system. There was little encapsulation. There was really no way to enforce separation between plugins. So one bad plugin could do pretty bad things to a system. With the module system in OSGi, we can really limit the way plugins interact with each other and the way that plugins interact with the host application. This is kind of a double-edged sword for you plugin developers. I mean, on the one hand, it's great for us because it increases application security and so forth. But on the other hand, some of the components that you may be used to using may no longer be exported to the plugins to system, so you might have less power. I'll talk a little bit more about what you can do about that later on. The second benefit is that OSGi eliminates a problem that I like to call jar hell, in analogy with DLL hell in the Windows world. The easiest way to explain this, I think, is to think about a situation where you're creating a plugin and it depends on, or it uses 2 libraries. And those 2 libraries, in turn, depend on some common thing like a logging framework. but they depend on different incompatible versions of that logging framework. In the pre-OSGi world, you were in a world of trouble there because basically the class loader wasn't flexible enough to let you load two versions of a library simultaneously. So either the two libraries would be incompatible, or they might work, but it might just be a coincidence. That's jar hell. And OSGi gets around this problem by this module system, which allows you to dynamically have multiple copies and versions of a given library around. So for example, if I need Google Collections 1.0 and your plugin needs Google Collections 1.1, no problem. We can have both versions running simultaneously side by side. The third benefit of OSGi is one of speed. So the lifecycle layer that I was talking about earlier lets you do cool things like if you're a plugin developer, you can dynamically update your plugin in the plugin system without redeploying the application or anything like that. So for a plugin developer, there's a big speed advantage. Your development speed will go up substantially thanks to OSGi. For the admins in the room, OSGi also has a number of benefits. You can now dynamically install plugins, and that really wasn't available. Well, it was available in Confluence, but now it's more universally available. So speed is another benefit of OSGi. Finally, we're building a lot of tools, and the tools that we are building really require plugins to an OSGi. So we're building things like the Atlassian plugin SDK, which gives you a lot of functionality, and a lot of that functionality is really only going to be available if you're building a plugins to plugin. Another thing that we built is the Universal Plugin Manager, which works much better with plugins to plugins. So if you want to maximize, if you want to take advantage of these tools as maximally as you can, you're going to want to build a plugins to plugin. And so we're really encouraging plugin developers to migrate to plugins to, which leads me to this next slide. How do you actually migrate to plugins to? Well, that's not really the purpose of this talk. So I'm gonna defer that to some documentation pages that we've got written. So the first documentation, well, let me describe it in terms of steps. The first thing you'll need to do to migrate your plugin is take your Atlassian plugin XML and convert it to a plugins to plugin. And there's instructions to do that on the first link. And I should mention that all of this stuff is going to be available offline later, so you don't have to furiously scribble these like little shortened URLs down. After you've converted your plugin to plugins to in your plugin metadata, the next thing that you'll probably want to do is convert your plugin project to use the plugin SDK. Ben spoke a lot about the plugin SDK earlier, and I'm going to highly recommend that you use it. There might be some reasons why you don't actually want to use the plugin SDK. For example, in the Universal Plugin Manager, we needed to do some things that the plugin SDK itself couldn't do. So we ended up dropping down and using the core of that, which is the AMPs stuff that Ben alluded to. So if you're building an extremely complicated plugin, you might want to use AMPs. But for the vast majority of you, I would recommend converting your plugin to use the SDK. OK, so let me continue by kind of describing the relationship between OSGi and our applications. Our thought on OSGi, our intention has always been to hide OSGi as much as possible. So our documentation states that, well, we try to hide the complexity of OSGi. So if you're building a simple plugin, you don't need to worry about OSGi. But if you want, if you're an OSGi developer, you know a lot about OSGi already, you can do things to leverage all of OSGi's features. Graphically, I kind of think about the situation as follows. We have a graph here of OSGi knowledge versus plugin complexity. Now, if you're building a simple plugin, like a gadget, something that requires little Java code, maybe it's just some XML and JavaScript, you really don't need to know about OSGi. The plugin system is going to automatically convert everything to an OSGi bundle for you at runtime. On the other hand, the other end of the spectrum is if you're building some kind of crazy cross-product plugin, like dashboards or the Universal Plugin Manager, you really need deep, intimate knowledge of OSGi. Unfortunately, that's usually where my team sits. We're dealing with OSGi issues a lot of times, almost daily. But I think the awesome thing about the plugin system, the thing that it's done really well, is it has this really broad sweet spot. So for the vast majority of plugin developers, it's beneficial to know something about OSGi. It'll really help you when you're debugging, and it'll really help you in your development lifecycle. But you really don't need to be an expert. You just need to know this bare minimum. And that's the intention of this talk, is to kind of get you to that minimum level of knowledge. So continuing on with our agenda, that was my sort of 10,000-foot OSGi view. I'm going to continue by diving down a little bit more deeply into OSGi. So I've been alluding to OSGi this whole time. And I've sort of been throwing a lot of concepts around. And it is true, OSGi is a complicated beast. But I think if you really want to understand OSGi as an Atlassian plugin developer, the main concept that you really need to know about is the notion of a bundle. If you know a lot about bundles, you can get by pretty far. So I'm going to spend most of my time talking about bundles. So a bundle is basically the unit of modularity. It's what defines the module system in OSGi. And for plugin developers, you should know that your plugins 2 plugin is dynamically transformed into an OSGi bundle by the plugin system. So for the purposes of this talk, you can just use bundle. I'm going to use the words bundle and plugin kind of interchangeably. So I'm going to delve a little bit deeper into what an OSGi bundle is now. The analogy that I like to use is that an OSGi bundle is kind of like a puzzle piece. And what I mean by that is every plugin in the system is kind of like a puzzle piece, and they can interact with each other. They can be wired together to form the whole puzzle. A little bit more concretely, an OSGi bundle actually is just a regular old Java jar, but there's some additional stuff in there. So you take your jar's manifest, and you can put in additional metadata entries that are OSGi specific. And that's what defines the behavior of your bundle to the OSGi runtime system. And I'm going to explain the details of the manifest contents in a later slide. Besides the manifest, there's other stuff that makes up an OSGi bundle. There's an activator, there's services, and I don't really need to talk about those for the purposes of this talk. If you want more details, I can talk to you offline about those. An important thing to notice is that every OSGi bundle has its own private class loader. And that's important because that's how the modularity and encapsulation happens. Basically, each OSGi bundle by default is isolated from every other bundle by this private class loader. It's only allowed to look at the classes within its own bundle. Now, if you want to interact with another bundle, the way that you do that is through package imports and exports, which I've depicted on this puzzle piece by these sort of like negative and positive components of the puzzle. I don't know how else you would describe that. Basically, you can define a dependency by saying, I require this other package, and then another bundle that exports that package will be able to provide it to you. Another picture of that would be as follows. So, for example, if I built a plugin that has a dependency on Google Collections, the way I would specify that in my plugin is by doing an import package on something like com.googlecollect. You can also specify a version number in there. And what the runtime system will do is when it sees that import package declaration in your manifest, it will try to find another bundle that exports that package. If it can find so and the versions match, then what it'll do is it'll create a wire, which is basically a hook for your plugin's private class loader to connect into this other bundle and be able to load classes from it. So that's kind of how bundle dependencies work. So I really think that's basically the fundamentals that you need to know about OSGi in order to start building an Atlassian plugin. I'm going to continue with a bunch of little tips and tricks that I've learned in my tenure in the integration team in San Francisco. So my first tip is that you should master the manifest. So you should become a master of your OSGi manifest. I've got this really tiny font here. You don't need to look at the specific words because I'm going to blow up the individual entries in a second. But what I mean by this is, so when the SDK creates your plugin, it will actually create a manifest. You can look at this by exploding your jar and looking in the normal place for that you would for a manifest.mf file. And you'll see stuff like this. And I'll walk through the entries that are interesting one by one. So first, there's a bunch of manifest headers that essentially name your bundle. There's a bundle name, a bundle symbolic name, and a human readable description. Those are all generated from your Maven POM if you're using the SDK. The next thing that I want to point out is a bundle class path. Now,
are they generated if you're not using the SDK right now, but you're using the Maven archetype?
Not by default. I'll talk about that in the next slide. There's like a couple caveats regarding that. I'll talk about that in a second. So the next manifest entry is the bundle class path. The bundle class path allows you to specify private libraries that are actually embedded in your plugin. These are, by default, not going to be exported or made available to other bundles. And again, I'm going to have a later slide that talks about why you would use the bundle class path, the advantages and disadvantages of using that over import package, which is the next thing that I want to show you. So this gigantic import package declaration defines all of the packages that my plugin is using it's expecting to find dynamically provided by other plugins or bundles. So in this particular example, I'm saying I require COM Atlassian AGMP integration common, and I specify a version number. Now these are just Java packages. It's important to note that. But these are all the things that I'm expecting to resolve dynamically from other plugins or bundles. And if one of those can't be resolved, then my plugin will actually fail to start. The dual of the import package is export package. These are packages that I'm providing to other plugins or bundles. In this case, I'm providing COM Atlassian AGMP gdata. There's this other thing called uses, and I actually don't want to talk about that. It's a little bit complex, but you can come and talk to me anytime if you want to know what that does. OK, so back to your question. How are these manifest entries generated? Well, if you're using the SDK or you're using the Maven stuff, the Maven plugins that we define, if you provide an instructions section in the configuration, then those entries will be generated for you. Now, if you have no instructions, it'll actually leave an empty manifest in there. And then the plugin system will try to do all this stuff dynamically. It'll figure out the import-export packages, and it'll just produce those dynamically, and you won't ever see them. If you provide at least one instruction, then it'll auto-generate all of them. So for example, here I've specified my import and export packages. All of those other entries, like the symbolic name, would be auto-generated. Internally, this is using another Maven plugin called the Maven Bundle plugin to do all the work. As a best practice, I would highly recommend that you define your import and export packages yourself. I wouldn't rely on the plugin system to do that for you. The reason that you want to do that is because you want tight control over over the wires in your plugin. OK, continuing. I got a question. Yeah.
So that means don't try and wire them together, the dependencies together using the Atlassian plugin.xml file. It should be specified in the Maven POM.
Yeah, you want to do it in the Maven POM. That's right. I mean, so basically the Maven Bundle plugin will do bytecode scanning to determine what it needs to put in there. So it can do it for you. One thing that you can do as an option is if you put nothing in there, one of the Maven plugins that we have in AMPS will actually warn you that you're missing something, and it'll spit out a list of all the packages that it thinks you need to import. So you can start from that list and then manage it yourself after that point.
So this is outside of the import statements in the Atlassian plugin XML?
Yes, that's a separate thing. OK, so my next tip is about dependency management. So I'm going to give you a couple best practices about dependency management in general in the OSGi world. The first is that there's actually a couple ways that you can declare dependencies in a plugin. One of them, which I've shown you, is import package. So you can say, I require the Java package com.googlecollect. Wire me up to somebody that provides that. Another thing you can do is something called require bundle. If you're familiar with OSGi development from like the Eclipse world, like you've built an Eclipse plugin, you may have seen require bundle because it's used more frequently there. Require bundle says, instead of give me this package, require bundle says, provide me a bundle with this particular name. So it's like saying, give me all of Google collections as opposed to give me a single package. Now that might seem awesome. That might seem like the way you want to define your dependencies, but it's actually a bad idea because there's a subtle difference between import package and require bundle. That subtle difference is that in the standard world, import package, we've got the scenario on the left, on that side of the slide, which is that you're just wiring bundles together. The other picture with require bundle is more like you're taking another bundle and you're shoving it in your bundle. So that's like taking a puzzle piece and shoving it into another puzzle piece. And that's bad because actually, when you do that, you can actually access private packages in that bundle that you've embedded, which is a bad thing to do. You should always use import package if you can. So continuing on this dependency management kick, there's another way that you can specify dependencies, which I alluded to, which is bundle class path. If you looked at my manifest earlier, I had this bundle class path, and I had a bunch of jars specified there. That's another way that you can depend on other libraries. And the difference, again, is quite subtle. In the one case, you're requiring on other OSGi bundles. In the bundle class path case, you're actually embedding those jars in your plugin, and they're only available privately to your class loader, which is actually a good thing some of the time. The problem is if those classes leak out outside of your plugin or leak into your plugin, you're almost certainly going to get an exception thrown at runtime, because basically those classes are totally private to your plugin. No one else knows about them. So for example, if I bundle class path Google Collections, I have a private copy of Google Collections. If I have a method that returns something of the Google Collections types, like some kind of map or something like that, that Google Collections knows about, nothing in the outside world is going to be able to interact with that because the classes aren't going to be compatible. So whenever possible, you should try to use import package over bundle class path. On the other hand, there may be situations where you can guarantee that you're the only one using this package. It's internal to your plugin, and therefore you can safely use bundle class path. So if you'll notice, so I want to talk a little bit about version specifications in your dependencies. You should always specify versions in your dependencies. That's just a best practice. If you'll notice the manifest that I showed you earlier, it had a bunch of version specifications in it. So let me decipher those for you here. Versions are actually specified in major, minor, micro qualifier form with dots separating them. The first three, major, minor, micro, are all numeric, and the last is alphanumeric. It's just an arbitrary string. And these are ordered the way you would expect them to be ordered. They're numeric, and then the qualifier is sorted lexicographically. If you look at the bundle constraints that I specified, I was always using an equal sign. So I was just saying version equals 1.0 or something like that. In fact, you can specify entire interval ranges. So you can say, give me Google Collections anywhere between 1.0 and 2.0. And you can use that, you can specify that using this range notation. Closed bracket means inclusive, brackets mean inclusive and parens mean exclusive. It's like from high school math. So for example, you can say 1.0.0 with an open bracket to 2.0.0 with a closed paren. And that means version 1.0.0 including 1.0.0 to 2.0.0 excluding 2.0.0. So you can be very fine-grained with these dependencies if you need to be. The interesting quirk about OSGi is that the upper bound, if you leave it off, a missing upper bound means infinity. So like version 1.0.0 actually means greater than 1.0.0. So they've redefined equals to mean greater than in OSGi land, which is awesome. So if you see version equals 0.0.0, that means any version in the world. And then last but not least, don't forget to put your version constraints in quotes. If you leave off the quotes, I think something bad happens. By default, if you do something wrong, something bad happens. So yeah. Yeah, well, yeah, BP, I'm pretty sure they forgot a version constraint somewhere. So the last thing that I want to say about dependency management is that in the OSGi world, you have to be very careful about what you're actually pulling in. That's kind of been a theme of this whole dependency trip that I have. So one way of doing that is by using the Maven dependency tree command. So if you run Maven dependency tree, you'll see actually a big dependency graph of all the packages that you're pulling in your plugin. You can use that and scan them manually and try to figure out why. Just try to have a good handle on why you're importing things. So know why you're importing things, and if you don't need something, pull it out, exclude it, you don't need it. If you're paranoid, we have a plugin that was built internally at Atlassian called the Maven Dependency Tracker plugin. There's a link there. What this does is you can basically say, like, I don't ever expect my dependencies to change, and if they ever do, fail my build, and then let me look at the differences and see why that happened. So that's a handy thing if you're feeling paranoid. OK, so my third pro tip is about OSGi class loading, which is a complicated topic. And I'm going to try to simplify it as much as possible in this slide. So this flowchart is like 1/3 of the actual algorithm for class loading in the OSGi world. So yeah, you can't earn a black belt if you understand this slide. You just get a brown belt. It's not quite as awesome. So in the standard Java world, class loading was a pretty simple affair, right? There was this parent delegation model, and class loading was decently simple. OSGi kind of changes class loading so that instead of like a single tree or a chain of class loaders, you basically have like a big graph that runs around dynamically, and the graph is defined by all those wires between bundles that I described earlier. I see somebody shaking their head. I guess I'm oversimplifying things a little.
No, that is. It's just that it's, yeah.
Yeah, that's awful. Yeah, I don't know. Love it or leave it. That's what we got. So let me kind of walk through the algorithm for class loading in the OSGi world. The first thing that happens is if you're trying to load a class, we check to see if the class is in the java.star package. If it is, then we delegate to parent class loading. So basically, if you're building a plugin and you rely on the Java JDK classes, like Java Lang, whatever, that's just going to work. You don't need to do anything special for that because the OSGi system will essentially skip all of the OSGi class loading mumbo jumbo and just go back to the Java way of doing things. And the interesting thing is there's another set of classes that works the same way. It skips the OSGi model. Those are called boot delegated packages. So basically, when you start an OSGi container up, we have an OSGi container running in our plugin system. When you start that up, you can give it a list of packages, and you can say boot delegate these. If you boot delegate a package, it basically does the same thing as it would with java.star packages. It totally skips the OSGi model and goes back to the standard Java way of doing things. Interesting thing about that is we don't tell you what we boot delegate, and it's really hard to know what's being boot delegated. In fact, I can't even figure out a way to look at a running Jira instance or whatever and determine what's boot delegated. The only way to change that is to actually put a system, change a system parameter. And you don't want to do that. You can't expect your customers to change a system parameter on startup so that you can unboot delegate something or something. I'm going to talk a little bit more about boot delegation in the next slide, but I want to continue with the OSGi way of class loading, which is the bottom half of this slide. So once we get past the java.star stuff and boot delegation, we actually go into the OSGi algorithm for class loading. The first thing we do is we look at your class, and if it matches one of the packages in your package import, then we actually go out into the wires and figure out where we should load that class from. So that's figuring out which bundle to load a class from. Now the interesting thing to note here is that last entry, the bundle class path on the left-hand side of the flowchart. So the bundle class path, you'll notice, only gets searched if something is not in package import. What that means is if you package import something and it can't find a bundle dynamically, it's going to fail, even if you provide a copy of that package locally in your plugin. So if you package import something, somebody had better provide it or you're going to fail dynamically. So keep that in mind. OK, so back to boot delegation. If you'll look back at that flowchart, if a package is boot delegated, there's pretty much no way you can override that. There's basically one true copy of that package in the entire system, and there's really no way to get around it. You can't, say, stick a private copy of that library in your plugin. That just won't work. Nothing's going to fly. So the best thing that I can do is tell you what we boot delegate, and maybe that'll make you feel better. So the first thing that we boot delegate is profilers, like com.yourkit. The reason that you do that is because if you're using a profiling tool like YourKit, you want all the bundles in the system to be profilable without actually having to manually import everything. So stuff like that, just let everybody import that. That's cool. The interesting thing is that we boot delegate Xerxes. And there's a long and involved trail as to why that happens, and it's pretty awful, and I don't want to get into the details. But basically, you need to know that there's one copy of Xerxes in the system. So if you're doing XML parsing, I hope you like the version of Xerxes that we ship in our products. Yeah.
What about Jersey? Is that true for that as well?
Jersey is not boot delegated. Jersey is provided by our REST module. So you can actually, any product that has the REST plugin installed, which is any of the latest releases, you can actually get a copy of Jersey for free just by doing import package. So I would recommend doing that. OK, my next pro tip after we get past this whole class loading fiasco is there's a tool called the Felix Web Console, which is awesome. The cool thing about the Felix Web Console, this is a servlet, by the way. The cool thing about the Felix Web Console is that we automatically set it up for you if you're using the plugin SDK. So if you're using the plugin SDK and you do Atlas Run or Atlas Debug, if you navigate to the right servlet, whose address is totally cryptic, and I'll reveal it later, you get this awesome view of the entire OSGi runtime system that you can investigate. So zooming in a little bit, each of the entries in this table is an OSGi bundle, or another plugin, if you want to think of it that way. On the left side of the table are numbers. These are unique bundle IDs. So at runtime, every bundle is given an ID. In this case, Atlassian Template Renderer API has been given bundle ID 50. On the right-hand side of this table is the state of that bundle. Active means that everything happened perfectly. So the plugin loaded, all the classes were resolved, everything's kosher. If you see something other than active, that means something failed dynamically. Probably It could be like a wire resolution issue, something like that. So if you start your plugin, you bring up the Felix Web Console and you see installed, check your logs because it'll probably tell you what it couldn't resolve. Or instead of checking your logs, you can expand any of these entries and it'll tell you what it couldn't resolve. So the cool thing about looking at these, so all of this is OSGi metadata, all the stuff that I showed you in the manifest, but it's put in a nice, easier to read form. The cool thing about this is you can debug wires right from here. So for example, if I look at my imported packages, I used that common Atlassian template renderer API package, bundle ID 50. You can see that I'm using it down there, bundle ID 50. And you'll see a bunch of red down there if there's an import package that didn't resolve properly. So that's a great way to debug OSGi class loading issues. Now, like I said, you're going to get this for free if you're using the plugin SDK. You're going to want to go to the base URL of your running product and then go to Plugin Servlet System Console. You'll need to authenticate. The credentials are admin, admin. And the awesome thing about this is like you try to authenticate and it like fails out. You authenticate again, it fails out. You hit refresh and then you're in. So trust me, it does work. It just takes a little bit of wrangling. Another option is to use this new plugin that just came out. It's in the plugin exchange. It's called the OSGi Explorer plugin. This is Confluence only. And what it does is it basically gives you the same view as the Felix Web Console, but in a nice, fancy Confluence macro. You grab that from the plugin exchange, and it's Confluence only, like I said. So if you're building a plugin for another product, you don't get this. OK, my last tip is to know what the applications provide. Now, I was mentioning earlier that with the OSGi module system, we don't actually export all of the host components anymore. So if you're building a plugins 1 plugin, you might migrate to plugins 2 and realize that something you were using is gone. So how do you know what is available to you? Well, if you're using Confluence, you can use this awesome page, the exported beans page. You can navigate there from base URL admin plugin exports.action. If you're building a plugin for another product, I really don't have a lot of great stuff to tell you. There's the Felix Web Console, so I would just use that. Just look at the Felix Web Console and poke around and see what bundles are around. So to recap, I gave you a bit of a background, a little bit of a dive into OSGi and the Felix world, and I gave you a bunch of tips on how to be more productive in your plugin development. So I hope this was instructive to some of you. And the resources are available here, and I'm happy to take some questions.
I'm just doing internal plugins, and so I guess I can get in and rip apart something when I need to. Is there a place that's restricting what Atlassian packages I can import by default?
Sorry, can you say that one more time?
For example, I know com Atlassian gadgets system. That package in Jira is not available.
Yeah, I would, like I said, I would just look at the Felix Web Console. That's the best advice that I have for you. I don't have much more than that, unfortunately.
Okay, so if I go in, but if I go in there and I see that it's not there.
Yeah, that sucks.
I got something to say.
Yeah, I would talk to the developer relations team because they'll be able to do something about it for you if something that you need is not available. Yeah, that's a better answer.
So my name is Matt Dorr, and I wrote the page Plugin Gotchas up there on the last doc sprint. And the reason I wrote that is because I have spent so many days trying to get these OSGi 2 plugins working. I'll be sitting there on a customer site and sweating because specifically for Jira, you know, you've mentioned this a few times, there's just a lot of empty spots in the actual, how do I do this? How do I get this working? There's seemingly an infinite series of different errors that come up.
Yeah.
And it's not clear to anybody, including dev relations, I'll guarantee you, and support, just how to debug these to get Jira plugins working in OSGi 2. It's a real concern.
Is there a question?
No, it's not a question. It's an absolute statement that the current state of Jira plugins is very difficult to maintain.
So let me speak to that for a little. That page that you wrote is great. I've seen that, and I actually started the first version of my talk was based on that. I just had so much to say that I couldn't fit everything on that page.
I like this talk, and there's useful information here, and I'm positive about where we're going. But
yeah, so the direction is very positive. So and there's a new release of the plugin system, plugins 2.5, and at the very least, the error message, we spent a lot of time on the error messages. So when something fails, your log will contain a message that is suggestive of the root cause of the problem, which is a real problem in OSGi.
That's an advance.
Yeah. Yeah, no, it's a tough thing because the OSGi messages, the root OSGi messages that you get are mad cryptic. Like you just can't understand them. So the plugin system is doing a better job with those error messages. If you run into those problems, again, see the error messages. If they look better, that's great. If not, then obviously feedback would be totally welcome.
Yeah, I think what's really wanted is some way for people to say, okay, I want a better way to debug my plugin than just pasting in cryptic error messages to the forum or Googling it.
Yeah. Right.
Understanding stuff like this is a start.
Yeah.
And this is enormously helpful, but there's a lot more to go in the documentation before you could say that this plugin system is really usable.
Honestly, from my perspective, like I didn't build the plugin system, but I use it a lot. Yeah. So I'm more of a user than a framework builder.
Probably. Yeah.
The first thing that I do when I run into an issue that I think is OSGi related, and you usually know it's OSGi related if your plugin just doesn't come up at all.
Or it has some random runtime.
Yeah. So if that happens, the first thing I do is go to the Felix Web Console. And then that'll tell me, okay, the root cause is I didn't wire something up properly or something like that. Mm-hmm. It's very instructive. And then from there, I go to the logs. And like I said, with the plugins 2.5 system, the log messages are much better. So hopefully the world is improving. With the Universal Plugin Manager, we were using plugins 2.4, but things got a lot better from my perspective. So I hope that pretty soon that'll be filtering out to you guys.
Do you know when 2.5 is due?
The next release of all the products, so that's Confluence 3, I believe, and Jira 4.2. Yeah, that'll have plugins.
I think one of the things that I've heard from a number of plugin developers is that, okay, there's a missing class, and I need to provide it somewhere, but is it going in the jar file? Is it going in some random class path? How do I modify the pom.xml, the Atlassian plugin.xml? There's a lot of this sort of, just what should I do to debug it? And that's what's missing in them.
Yeah, so I think I tried to outline that in the talk, the ways that you can declare dependencies via either import package, require bundle, or by embedding them in your plugin.
Right, but this is what I should do. I don't know, how should I debug it when it doesn't work?
How should you debug it when it doesn't work? I mean, the best answer that I've tried to give you the best answer that I can from these tools.
Yeah, thank you.
More questions?
So it's really a question about plugins generally rather than OSGi. But supposing, like we do, we have a bunch of private plugins that we want to deploy into Confluence and Jira. Is there a way that we can get our own plugin repository and point our Jiras and Confidences at it?
No, the question was asked, the same question was asked earlier, and
sorry.
Well, Jonathan answered it, but I'll repeat his answer. Basically, we're open to the idea. We want some feedback as to why you would want that and what it would do, and then
I can give you lots of reasons, but we would love it.
Yeah, so I would talk to Jonathan and the dev relations people for that.
Hello. I'll start by answering a question first, and then I'll ask my question. In order to, if you're needing to get access to a component that's not exported and you don't mind modifying the web app, look for the Spring XML files inside of Confluence, and it's the plugin :available equals true. Set that, and you can import it. It won't be there the next time you upgrade, but it's a good way of digging in. Yeah, just make sure you do an import of the package, otherwise you won't have the class. Yeah.
Good times.
The question is. The question is newer versions. For example, Felix Console doesn't work with Confluence 3.0 because
is that right?
Yeah, because of the version of plugin subsystem you're using.
Okay.
How tied to the version of the shipped application is the plugin subsystem, and can that be upgraded independently of the application?
Oh, yeah. You're not going to, no, don't do that. Really, don't do that. Yeah, because we're doing things like changing the Felix version in releases of the plugin system, so everything is changing. Yeah, it's a dangerous world you're living in if you try to do that.
Hi. So, I mean, like Matt's done, I mean, I've played with plugins too several times, different platforms, always having interesting problems. I like a challenge. So you have classes which get dumped out in WebInf classes. You've got libraries that are WebInf lib. You've got OSGi bundles. Each of them has their own kind of reasons for being deployed in that way. When you have things that cross the boundaries, so you use a library from over there, you're referencing classes in WebInf classes, and you're trying to get handles on OSGi bundles. Yeah, that's kind of why I'm still at plugins 1. So the question is, I can see that you're trying to move application code into bundles. That's a process.
Yeah.
Great. At some point, maybe the entire application will be bundleized. I'm just curious to know that is plugins 1 going to stick around until you complete that process? Because
yeah, there's no plans anywhere to get rid of plugins 1. So so the things that I want to say about that, one, like I said, nothing on the roadmap for eliminating plugins 1, to my knowledge. 2, we're still encouraging everyone to start working with plugins 2, because a couple things about that. I mean, plugins 2, yes, there are a lot of pain points, but you can still build some amazing things. The Universal Plugin Manager is a plugins 2 plugin. We ran into some OSGi pain, that required some tweaks to the plugin system that customers wouldn't be able to do. But things are always getting better. And because we built it as a plugins 2 plugin and in a cross-product way, we can stick that in Bamboo and Fisheye Crucible with almost no work. So the gains are tremendous. The last thing I want to say is that I'm hoping that we move to a state where more things are bundleized, because as I pointed out in this talk, the best way to depend on other things is via bundles. So what I want to get us to a point, and this is just kind of me on a crusade at this point, but hopefully other people will follow along. I want to get us to a point where we define what bundles we're going to ship with an application, define those versions, and guarantee that those are going to be available, so that if you build a plugin and you require a bunch of bundles across an upgrade or something, we're not just going to take those bundles away from you and leave you high and dry with respect to your plugin.
Okay. Last question. The use of bundled private libraries.
Yeah.
I'm wondering over time if people start bundling copies of a specific version. I mean, the memory footprint.
I've got a great answer to that. So I wouldn't worry too much about the actual space on disk that those copies are taking. What I would worry about, again, is like you mentioned, the memory footprint of loading multiple copies. The best practice there, I actually had a slide on it which I hid, is to do what's called a self-wire. So what you can do is, if you have a private copy of something, you can actually say that you both import and export that packet, that library. What that does is if no one else provides it, you'll actually wire to yourself in the OSGi world. So that means you're in good shape, even if we take it away or something like that. However, the way the resolution algorithms work, if somebody else provides it, you'll prefer to wire to their copy. So that's really nice, because basically the OSGi system will try to maximally share classes to make the applications or the bundles as compatible with each other as possible. So the best practice is, if you're going to bundle something like that, do a self-wire. So both import the package and export it. And you can see examples of that. If you unjar the UPM, for example, you'll see that we self-wire a package called Jackson. And so you can use that as a template to do in your own plugins if you can.
Thank you.
Bundle resolution, if I'm depending on 5 other plugins or for logging or whatever. So bundle resolution. So how do I make, if I'm depending on 5 of the plugins, that's 6 jars for someone to install. Are there any plans to make it easier for dynamic resolution of my dependencies?
Yes, there are. Thank God. The UPM, so the Atlassian plugin SDK creates a file called a .obr. So if you use the plugin SDK, you'll see a .obr. The Universal Plugin Manager today, although it's not documented, can actually install these things. What those are basically bundles that contain other bundle dependencies. So you can say, like, I require these 5 bundles. And then the Atlassian plugin SDK will actually create a .obr file which will contain those bundles. And then the cool part about that is the runtime system will only install them if it needs to. So like you could say, like, oh, here's my plugin. It requires Google Collections as a bundle, this logging framework as a bundle. And then when you install that .obr file through the UPM, it'll go through and say, OK, do we need Google Collections? No, the application provides it, and it won't install it. Or do we need logging? No, the application provides it, and then it'll just install what you need. So that's kind of a preliminary thing right now. We're hoping to get to a stage where something like that is like maybe the way that you want to distribute dependencies.
Is that logic inside of the plugin manager, or is it actually inside the plugin subsystem?
It is actually it's in 2 places. It's in the PDK install plugin, so if you do a PI, it should work. It's also in the UPM. It's not in the plugin system itself because it's sort of an OSGi layer thing. It uses the OSGi bundle repository code, and we didn't want to stick that in the plugin system.
I think we're done with questions, and we are a bit over time, so it's a good time to stop. If you guys have any more questions, I think you can mob Jonathan outside the presentation.